In this activity, we'll be creating a program that utilizes the TryFrom and TryInto traits. Once you're ready, load up Visual Studio Code and we'll get started. Once Visual Studio Code loads, navigate to your Activities directory. We are on Activity 37, so double-click on a37.rs. Once the activity file loads, review the topic and program requirements. Attempt to implement a solution on your own with the video paused. Once completed, resume the video and I will demonstrate my implementation as well as provide insights to the activity topic. All right, let's get started. This activity topic is about TryFrom and TryInto. We have a summary. Basically, we need to make a library to convert hex color codes into their component color values of red, green, and blue. We also have a description of a hex color code, so we know exactly what it should look like and exactly what it should convert into. In our program requirements, we see that we need to create a program that converts a hex code as a string slice into an RGB struct. We need to implement the TryFrom trait to perform the conversion, and we need to utilize the question mark operator in the implementation. In addition, we have some notes here. We can take a look at the fromStir_radix function to see how to convert from a hex digit into an 8-bit integer. We can also utilize the thisErrorCrate for our error type to make it easier to utilize. And we can run cargo test to test out the implementation. So if we take a look at the existing code, we have our RGB struct defined already. And in our main function, there's a comment that we should just use cargo test to test the implementation. If we take a quick look at the test module, all it's testing for is ensuring that we have a proper hex color code. So it's checking for invalid digits like right here, and it's testing for invalid length, missing the hashed code. So the first thing I'm going to do is go on over to the cargo.toml file. I'm going to add the thisErrorCrate. You can do so under the dependency section. So it's going to put in this error, and we'll use an asterisk. An asterisk just means pull the latest version. Once that's done, we can close the cargo.toml file and get back to the code. Now we can use the crate and the trait. So we'll use the trait first. So we'll use the TryFrom trait, because in order to use TryFrom, we have to import the trait from the standard library. We can also use the thisErrorCrate, and we're using the error macro. The next thing I'll implement is an RGB error enumeration, and this will be the error that's utilized when we try to convert color codes into the color components. We'll need to derive debug and error for this type. The first error we might encounter is missing the hash code, so we'll make a variant for that. We'll also make one if the hex digit is out of range of a hex number. So that'll be a parse error, so we fail to parse it into a number. And then finally, we'll have a length error. So we have to have 3 sets of 2 hex digits, so we'll just call it a length error. And that will occur if we have less or more than what we want. We should use the error macro to provide a good description for these. So hex colors must begin with a hash. And we'll put the hash symbol so the user knows. And then we'll have parse error, failed to parse hex digit. And then we'll also print out the description. And we'll have a length error. That will be invalid hex color length. For our parse error, we're actually going to use the standard library error. So that's going to have a variant data of parse int error. And that's actually available in the standard documentation. So if we hop on over to that, we can see we have the fromStir_radix function, which the instructions indicate we should be using. And if that fails, we get a result, and the parse int error is the error type. So we're just going to use that error, and it's going to be placed as a parse error variant within our error enumeration. Now that our error is complete, I'm going to start implementing the TryFrom trait. So I'll go down here, make some room. So we'll implement TryFrom, and we'll try from a borrowed stir, and that's going to convert into an RGB type. You have to set the error type that might occur, and the error will be the RGB error we just created. And then we'll have the TryFrom function. That's going to take a hex color code as a borrowed stir, and that's going to return the result. And that'll be self error. So when we implement the TryFrom trait, we have to specify the type of error that we're returning, which is an RGB error. and we can use self to access the data. So we have self, which is just an RGB, and self error, which is this error here, which is an RGB error. So this self just makes it a little easier to reason about it, so we can easily change these later if we need to. The first thing I'm going to check for is the hash code. So if hex.startsWith, it's a function just to ensure that the string starts with a certain character. So if it starts with a hash, then we'll return an error, RGB error, missing hash. And we want this to occur if we don't start with a hash code. So we just use exclamation to negate that. And then we'll just return the missing hash error as our error. The next thing I'll check for is to ensure that the hex color code has the correct number of digits. So if the length is not equal to 7, then we'll return an error. We're using 7 because we have 6 color components, but then we have to include the hash as well. So the hash symbol is a character as well. And we'll return a length error. And so that way we'll know that we have an invalid length for our color codes. Now, if we reach this point in the code, we know we already have a valid color code. So now we can actually decode it into the color components. So we'll have an RGB, and that will be a tuple. So I'm going to put all this into a tuple. And we'll use the U8 type, and we'll access the fromStir_radix function that's indicating the instructions. What I'm going to do here is we're going to borrow the hex digit string. We're going to slice on it. We're going to slice from indexes 1 through 2. We're using the inclusive range operation, so we're going to get 1 and we're going to get 2. We're also going to use base 16 since hex digits are base 16. So if we show an example hex, we have FF00AA. So 1 to 2, we'll get index 1 and 2. So we'll get FF. Now we just need 00 and AA. So 00 will be 3 to 4. And then finally, the last set of hex digits will be 5 through 6. Once we've converted these hex digits into color components, we can create a new RGB struct by using self RGNB. If we take a look at the structure itself, we'll see that the RGB struct is a tuple struct by the parentheses. So to construct it, all we need to do is use the parentheses here. And we also created a tuple from all these pieces of information. And so we can just pass in the RGB without issue. There's one more thing we need to take care of, and that is our error type. So if we look at our error type, we're returning an RGB error. But this fromStir_radix function, when we use the question mark, it's actually going to be returning a parseInt error. So we need to convert the parseInt error into an RGB error. To do so, I'm just going to implement it. So we'll do implement from, and we'll use the standard library num parseInt error for RGB error. We'll implement the from function. The error will be a num parseInt error. That will just return itself, and we'll create an RGB error, and we'll use the parse error variance, and we'll just place the error within it. So whenever we get a parseInt error, it's going to get stuck in here as a parse error variance on the RGB error type, because that's self. This should cover all the edge cases, and we should be able to use the TryFrom function and run the tests. To run the tests, we'll need a terminal, so go to terminal, new terminal. We're on activity 37, so run cargo test --bin A37. So it looks like I have some errors, so let's start at the first one. And it looks like I just misspelled RGB error. So I'm going to go fix that now. It's on line 42, so this should be RGB. Now we can try again. And another spelling error. All right, that should cover all of them. All right, and now all my tests pass, so we have 5 out of 5 covered, and everything looks good. There's one more thing I want to show before finishing up. If we hop back to the code, we can actually just delete this implementation block completely and use the from macro right here in our variant. and that'll just implement the code automatically. So if we do a test again, we should get the same results. And there we go. So we don't have to actually write the implementation block, but it helps just for some practice. This concludes the activity video on implementing the TryFrom trait. I'll see you in the next presentation.